All right, this is the prelab for our investigating gas laws lab. First thing you're going to do is draw boxes and label them solid, liquid, and gas, and then put the particles in. And I apologize in advance, I'm not using my usual camera, so this is a little wonky. Okay, for the solids, you're going to put in your particles, and I want you to use arrows to show how fast they're moving. Liquids are moving a little faster, so the arrows will be a little longer. Gases are moving much faster. You guys can do that, so hit pause, get that done, and then hit play, and we'll go on. All right, so told you it's going to be rough. All right, here is an example of a solid, liquid, and gas that you might have drawn. Okay, kinetic theory of matter is the definition of why gases, what gases are doing and why. All right, we have to understand first of all that gas particles move randomly. All right, in various speeds, in all directions. So we're going to put these in here, but rather than me try to write, I'm going to give them to you in a PowerPoint form. Okay? So you've got gas particles move randomly in all directions at various speeds. Well, that's interesting. Particles which make up a gas each have a mass. No, I didn't want to do that. Distances separating particles are relatively large. The intermolecular forces, we love intermolecular forces, don't we? They're almost zero because they're so far apart. And finally, collisions between particles are perfectly elastic. Well, not finally, but one more. Meaning they bounce off of each other. They don't stick. And the average kinetic energy of a gas is proportional to its temperature. When we talk about temperature and heat, they're not the same thing. Heat is a measure of the total amount of something and how fast the particles are moving. Temperature is just the speed of the particles. All right, there are 4 properties that we need to understand when it comes to gases. First of all, oh, that's so cute. 4 main properties of gases. So you're going to put this into your notes as well. Pressure, volume, temperature, and the number of particles or moles. Pressure. Gases exert pressure on their surroundings. If you've taken physics, you know that force is equal to mass divided by area. If you have a balloon that you've blown up, the gases are pushing on the side of the balloon. They're pushing with a force, and that balloon has a surface area. All right? Pressure is related to the frequency of collisions between the particles and the walls of their containers. So the more collisions you have, the more pressure. Makes sense? Units used for pressure. We're going to use several different units. Pascals. Pascal was a scientist who started studying gases. Kilopascals would be 1,000 times, or 1,000. There are 1,000 pascals in a kilopascal. Atmospheres will use millimeters of mercury or torricellis. Millimeters of mercury refers to a barometer, which we will talk about later on, but basically a barometer is a large tube of mercury, and the mercury is, the tube's upside down so that the opening of the tube is in a dish of mercury. And as the pressure pushes down harder on the dish of mercury, the air pressure, the mercury will move up, and it's a higher pressure. If the pressure's not pushing as high, the mercury falls, and it's a lower pressure. Now, you're going to have to be able to do some conversions with this, but not for the lab. But this needs to be somewhere where you'll have access to it. Okay? Here's the definition of millimeters of mercury. Chemistry mostly uses the atmospheres. All right, to talk about volume. So another definition. Volume is related to the amount of space that something occupies. Okay? We're familiar with volume. You all know from math, length times width equals height. So if you've got inches, it's going to be inches cubed. If you've got centimeters, it's going to be centimeters cubed. If you have millimeters, you're going to have millimeters cubed. I don't know why my units are not showing up here. It's hard to see over here to the right, but 1 liter is equal to a cubic decimeter, which is equal to 1,000 cubic centimeters. All right, a liter is 1,000 cubic centimeters. 1 liter is also 1,000 milliliters. So what can you infer about the size of a cubic centimeter and a millimeter? They're the same. Okay? All right, our third characteristic is temperature. Temperature is related to the average kinetic energy of a substance. It's in SI units are Kelvin. Kelvins use the concept of absolute pressure. Kelvin and Celsius degrees are the same size, but a 0 degrees Celsius is the same as 273 degrees Kelvin. So you have to convert from Celsius to Kelvin. You have to add 273. We always use Kelvin in gas when we're doing gases. Always. All right, we're not going to worry about converting anything. Moles, finally, are related to the molar mass of a substance. You know how many moles are in a substance. You know the molar mass, and you can take the, if you know the mass of the substance, divided by the molar mass, you get the number of moles. That's just using our mole map. We know how to do that. All right. Discard the ink kind of notations and go back to this guy. So you've got your definitions there. That's your prelab.